Good morning. So today we are going to see about the 9-noded quadrilateral element shape function using Lagrangian interpolation. So the Lagrangian interpolation we have seen already in the previous class. Okay. So before getting into this topic, let's welcome to the Sakshi Academy. So this academy aims to bridge the gap between the industry and academics. So this is Lagrangian. This is a 9-noded rectangular element, or you call it as a 9-noded quadrilateral element. The node numbers are given with respect to the row 1, 2, 3, 4, 5, 6, and 7 and 8. And the coordinates are represented using eta and psi coordinate, that is a natural coordinate system. So with respect to the natural coordinate system, this element is defined in the corner and center nodes. For example, corner node number 1, since it's 0, 0, the nodes are given as a -1, -1. Because it's a natural coordinate system varies from -1 to +1, as everybody knows. Okay, so -1 to 0 coordinate were represented with respect to the 4th node, and -1, 1 with respect to 7 nodes. So similarly, all the nodes are represented. And here you see this element is represented, the node numbers are represented with respect to eta1, psi1 for our convenience, and eta2, psi2 for node number 2, eta3, psi3 for node number 3, and similarly up to node number 9, that's represented with respect to eta9 and psi9. So let's start with the shape function at node number 1. So the node number 1, the influential nodes are 2 and 3, the eta direction, 4 and 7 with respect to the psi direction. So the equation will start writing like eta minus eta2, that's here, and eta minus eta3, that's here. So similarly, eta1 minus eta2, that is eta1 minus eta2, and eta1 minus eta3, which means here in eta direction. Now we have to multiply with respect to the psi direction. Psi direction similarly represented, the influential nodes are 4 and 7, so psi minus 4 and psi minus 7. So that's been represented here. Okay. So the denominator will be psi1 minus psi4 and the product of psi1 minus psi7. That's been represented here. Now we have to substitute the corresponding values, eta2, eta3, psi4, psi7, eta1, psi1. So we have the values represented here. We have to substitute the exact values here. For example, eta2 is 0, so that's been substituted here. Eta3 is 1, so eta3 value is substituted here, and eta1 value -1, and eta2 value 0, that's substituted here, and eta3 value -1. So it's a good representation. It's easily been understood that once you substitute the values, you will get the shape function at eta into eta -1, and then psi into psi -1 by 4. This is a generic equation representation for shape function. Similarly, we have to find out the shape function for node number 2. So node number 2, the influential nodes are 5, 8, and 8, 5, 6. Okay. So we have to start with the equation with respect to psi direction, that is 5. So psi minus in this, the influential nodes are for the node number 2, 1 and 3, and in psi direction 5 and 8. So we have to write the equation with respect to this in psi direction, eta direction. So eta minus eta1, eta minus eta3. That's been represented here. Eta minus 1, eta 1 minus 3. So let's see the cursor here in psi direction. Eta minus eta 5, psi minus psi 5, psi minus psi 8. That's been represented here. So similarly, you have to write the equation according to the denominators in eta direction, eta 2 minus eta 1 and eta 2 minus eta 3, and psi minus psi 5, psi 2 minus psi 8. So this equation. Okay, the equation can be written as n2 equal to EC1 eta plus 1 eta minus 1 psi minus 1 by minus 2. That's been obtained by using the values are substituted into this corresponding equations. So please substitute with respect to your nodes and you will get this value. Okay. So we have seen the row wise 1, 2, 3. Similarly, we have to write for 4, 5, 6 and similarly 7 and 8 rounds. So for example, a different node has 5. So let's see for the fifth node how to write the shape function. Okay, for the fifth node, the influential nodes are 4 and 5 and 2 and 8. Okay. So now for the fifth node, how to write that equation? Eta minus eta 4, eta minus eta 6. You see here eta minus eta 4 and eta minus eta 6. And psi direction, psi minus psi 2, psi minus psi 8, psi minus psi 2, psi minus psi 8. So similarly, the denominators for the fifth node it's written. So eta 5 minus eta 4 and eta 5 minus eta 6. Similarly, in the psi direction, psi 5 minus psi 2, psi 5 minus psi 8. That's been represented here. So now you substitute the corresponding values been written here in the side of the element. Then you will get this shape function. Here, eta plus 1, eta minus 1, psi plus 1, psi minus 1 by 1. So similarly, you get for all the nodes, the equation will be in the form of, for the corner nodes, ni 1 by 4 eta psi eta plus eta I psi plus psi I. So to compare that, we'll take one node of set of 5. Okay. I copy this eta 1 and come to here and paste it here to compare the equation. You see now 1 by 4 eta and psi, you take it out here, and eta plus eta I, and for the each psi plus psi I. Okay, psi plus psi I. This equation for the corner nodes 1, 3, 7 and 9. These are the nodes, corner nodes. So for other nodes, eta equal to 2 and 8. The other nodes, eta equal to 0. For 4 and 6, psi equal to 0. So you represent the equation with respect to that. And central node n5 is represented with respect to the equation. Central node will be different. So you have to draw the function for central node differently. Okay. Once we find out the shape function for all the nodes, it's been computed with respect to the MATLAB. You get the shapes like this. For example, for the node number 1, you get the shape function value at 1 and the other values are closer to 0. Okay. So this is how the curves will be look like in MATLAB. You see the node number 1, shape function 1. So all the nodes taken for a particular node, it is 1 and other 0. So this is how the shape function property has been satisfied with respect to 9-ordered quadrilateral element. So any doubts, you please comment in the comment box. I'll be able to reply to you. So thank you. Please subscribe our channel for more interesting topics, engineering topics. Thank you.